just remembered. Okay, so the other applications that we looked at that we are supposed to look at, we have them here, they are listed. So they are saying that other applications of atmospheric pressure include drinking straw, sucking pad, siphon, rubber sucker, bicycle pump, and a water supply system. Now we are going to look at some of them, but what you have to know is that all these are applications. If they ask you state any application of atmospheric pressure, you can start with the force pump, the lift pump, then you go to drinking straw. Then now if they tell you with the aid of a diagram, if they tell you that with the aid of a diagram, explain one application of atmospheric pressure, then you can use the lift pump. You can explain the lift pump because you have the explanation there, you have the diagrams which are there, or you can draw the one of a force pump and explain the downstroke and also explain the upstroke. So if a question comes in the way that they are telling you that with aid of a diagram, explain any application of atmospheric pressure, go ahead and just draw a force pump and then explain the downstroke and the upstroke, or draw a lift pump and explain the downstroke and the upstroke. But if they tell you to just state, you just state a lift pump, a force pump, drinking straw, sucking pad, siphon, rubber suckers, like that. You just state, you don't need to explain much. So let us look at, so in your notes here, you can write other applications of atmospheric pressure, atmospheric pressure. So there are other applications that we consider. Amida. Yes, how are you, Amida? Amida, you have very poor network. Make sure that maybe you climb a hill. Yes. Your network is not okay. I don't know which service provider you are using. Are you using K2? You are using what? Okay. Now here she's speaking slow motion. Okay. So let us look at others. So we have drinking what? Drinking straw. You can first list them: drinking straw, sucking, suction pad. We have seen all these things. We have siphon. Maybe you don't know what a siphon is. We have a rubber sucker. And we have bicycle pump. And lastly, water supply system. Okay, those are about 6 of them. So let us look at one by one. Let us start, according to the notes, they are starting with the rubber sucker here. So what's a rubber sucker? I don't know whether I've ever seen something similar to that. Have you ever used the rubber sucker? Members, have you ever used the rubber sucker? Neha, have you ever used the rubber sucker? Or have you ever seen it?
I don't know.
You don't know it? Are you sure? People, you don't know what a rubber sucker is. Let me first see here and Google what's a rubber sucker. You have seen the things, but you are not sure. Haven't you seen the things which they use in toilets? These ones here. Huh? These ones. These are rubber suckers. This one here. Or
teacher, can I talk something about it?
You want to talk about something about
teacher?
them? Yes.
Yes.
Okay.
Like these ones are used in the toilet mostly.
Yes, these ones.
Yeah.
What about this? Hello, members. Do you get me? People. Okay, Lynette, I can't hear you. Lynette, I mean, I don't know what's speaking, but we can't hear each other. Okay, I think that was Farouk. Lynette. I don't know what's happening, but I think people have serious network issues. So these are rubber suckers, and this is what we are going to look at. So a rubber sucker is made in the way that if you compress it onto a wall, if you compress it into the wall, the air in between the wall and that rubber sucker moves out. It gets out. It is because you are compressing, so it gets out. And once the air gets out, it creates a low pressure. So here we shall have a low pressure here. And outside, there will be high atmospheric pressure. Now, that high atmospheric pressure pushes the rubber sucker to stick onto the what? Onto the wall. It sticks onto the wall. Why? Because inside there is low pressure compared to the atmospheric pressure that is outside. So a rubber sucker, once the rubber sucker is pushed onto the wall, the air is driven out, creating a low pressure between the wall and the rubber sucker. The atmospheric pressure that acts outside is greater than the pressure which is inside, and this atmospheric pressure sticks the rubber sucker onto the wall. So the main thing is that this pushing of the rubber sucker onto the wall is what drives out the air. Once the air is driven out, then the pressure that is in between the wall and the rubber sucker becomes very low. If that pressure is very low, then the outside atmosphere pressure is high, and that outside atmosphere pressure is the one that pushes the rubber sucker to stick onto the what? Onto the wall. Okay? Are we together? Members, are we together?
We are together.
Okay, good. So they're saying that this is a circular hole rubber cup before it is put to use, and it is moisturized to get good air seal and firmly pressed against a small flat surface. So the surface must be flat. You cannot say that let me put it on maybe on a stone. No, you can't put it on a stone because some stones do not have flat what? Surfaces, unless it's a polished stone and has a flat surface. But surfaces which are not flat, a rubber sucker cannot stick on those surfaces. Surfaces which are very flat, for example, glass can be very flat, so you can stick these window glasses. They're flat, so you can stick the rubber sucker onto it. So it is pressed firmly against a small flat surface so that the air inside is pushed out, and then the atmospheric pressure will hold it firmly against the surface. So what should we write about the rubber sucker? If they ask you, describe a rubber sucker as one of the applications of atmospheric pressure, what do you have to write? So the most important thing starts from here. Actually, it's here. You can say that when a rubber sucker is firmly pressed against, you can say, when a rubber sucker is firmly pressed against a small flat surface, comma, the air inside it is pushed out, then the atmospheric pressure holds the rubber sucker firmly against the surface or onto the surface. You can say against the surface. So when the rubber sucker is firmly pressed against a small flat surface, comma, this is very important, air, this one here, air inside it is pushed out, then the atmospheric pressure holds the rubber sucker firmly against that surface. So that's what you have to know. And you draw the diagram and you show the rubber sucker. Amida?
Yes, teacher.
They told me that you are a good artist. Is it true?
Artist?
Mm.
No,
That you also
I'm not.
you also fear yourself.
Teacher, no.
Who is this Amida? What's your other name? Amida Grace?
Grace. Yes.
Amida, I know you're a good artist. I know you
No, teacher.
very well. So it's like drawing a what? Drawing a cover top of a saucepan, and then you, and then you put it on a wall. So this is the wall. So inside here we shall have a vacuum. Can say at low pressure. Vacuum at low pressure. Then here we shall have, this is what we call a rubber sucker. And here we shall have the atmospheric pressure. Because atmospheric pressure acts in all directions, that's what you have to know. From up, from down, everywhere there is atmospheric pressure. So this is atmospheric RI pressure. And this is what we call the smooth flat surface. Smooth, and there should be the word flat surface. Okay, like that. All right. So that is the rubber sucker. So you have seen it is used for lifting things. Some people drop heavy things in the toilet, so you can use a rubber sucker and you remove those things. It is used also. It is used in printing machines for lifting papers to be fed into the printer. A rubber sucker. Also, it is used in printing machines. That's what you have to know. So used in printing machines. Where is it used? Where else is it used? Let us see. Where else is it used? By X. What's these are people are just selling. Where is it used? Where else is it used? I'm not saying where it is used. What is this one? So you can see this is the one they were talking about, printing machinery, this one here. For lifting papers, that's how it looks like. For lifting the papers. It is also used, we have this one here, but these are not rubbers. These are rubber suckers. Vacuum holder rubber suckers. I think these ones are used for lifting glass, okay? So it can also be used for lifting glass. Used for lifting what? Lifting glass. Okay, we can have those ones, those two uses, and then we can go to the next one, which is called the siphon. So look at the siphon. The siphon. What's a siphon? Who can tell us? What do you understand by a siphon? Siphon. What's a siphon? What do you understand by the term siphon? Or what do you know by a siphon? What's a siphon? Lynette, do you know what a siphon? Francis, you are there. Do you know what a siphon is? It's what? Francis. Let me first ask you to unmute each one so that we can hear each other. What's a siphon? Neha, do you know what a siphon is?
No, teacher.
Okay, let me first show you the diagram and then you are going to tell me how it works. Sorry. Let me choose. Okay, so let me choose this one here. That's a siphon. How does it work? Even this is a siphon. That long tube there is what we call a siphon. But I want you to, even this one is a siphon. Members, how does a siphon work? Who can tell us? Who can try? How does a siphon work? How does it work?
Teacher,
Yes.
a siphon, it's an equipment that is used to move liquids from one place to another.
It's used to move liquids from one place to another. Liquids from one point to another. What? Okay, good. What makes liquids to rise? Now you can see here the liquid is going to rise, isn't it? Let me show you one where we have liquid rising. Now, like this one here. Here the liquid rises. What makes this liquid to rise? Can a liquid rise like that? Can it go up? What makes it to go up?
The atmospheric pressure.
The atmospheric pressure. So there is atmospheric pressure where? Here or here? On the upper one or the downer one? On the downer one? Okay. Let us see a video of this siphon. Let me see this one here. Okay. Let us see this video and see what the siphon is. And you're going to tell me. So you see water is coming from there and it is entering into this one. But you can see that there is a distance. There is a certain height at which the one which has water, it is elevated up compared to this one which is receiving the water. So that is, who can tell me, why do you think they put this one up?
I think to balance.
To balance. Okay. Now, let's go back. Here is just making it, but let us see here. That is a siphon. This one is losing, this one is gaining. And the one which is elevated up is the one which is losing, and the one which is down, it is gaining. So why do they put this one up? Now it is not to balance, but the way how you have seen this diagram, which is here, this diagram, which is here. Let me first show you this diagram that is here. Where we are. Okay. The way you see this diagram, which is here, okay, there is a certain height h here. So that height h has got a liquid inside, and it means that this liquid is also matter. It has matter. We say that matter is anything that has weight, isn't it? And occupies what? Space. So it means that this liquid which is here has got weight, So due to the atmospheric pressure that is acting in this other container that is elevated up, that atmospheric pressure acts on the liquid in this container that is elevated up, pushing the liquid to rise through this tube. Once the liquid rises through this tube, it reaches this part. Now, at this point here, due to the gravity, or due to the acceleration due to gravity, or due to gravitation, that gravitation makes the water to fall through the pipe until it reaches to the tank that is at the bottom. So if you have a container which is at the bottom or a tank, that water will flow into that tank. Why? Because now this water which is inside in this pipe, this vertical distance here that I'm talking about, the water that is inside this vertical distance is acted upon by gravity or by a force of gravitation. And this water will fall freely into the container that will be placed at the bottom, making the water which is here to continuously rise into the pipe, and this one falls down. So the process continues until this container that is elevated upwards is empty and the container that is at the bottom here fills up. So there are two things that make the water to flow. Number one, the atmospheric pressure that is acting outside in this container that is elevated, that is acting on the liquid surface here. That atmospheric pressure is the one that pushes the water to rise into the pipe, okay? Now, when that water reaches point C up to E, it experiences a force of gravity, and gravity now makes that water to freely fall into the container that will be placed at the bottom of this pipe. So this continuous flow of the water will make the water in the elevated container to drain up, whereas in the container that is placed downwards to fill what? To fill up. Are we together?
Yes.
Are we
Teacher,
together? Yes.
what if I use a straw?
If you use a straw,
Yeah. Can it work?
which straw are you talking about? This one's for taking soda.
Yes.
You see, there are very many straws. There's also this one for taking this drink they put in pots. Do you know it?
Yes,
Yes.
Mara.
So that one is also straw. So which straw are you talking about?
Even that, teacher,
One for
Eh?
taking soda.
teacher.
That
Even
one
these
for,
are other straws for milkshakes.
for what?
Milkshakes, the bigger
For
ones,
the
which are
bigger
big.
ones. You see, people like to go to Cafe Javas. Have you heard of them? So the straws that you are talking about for taking soda, they may be short, but if you connect them, are you listening?
Yes.
If you connect them and you make sure that where you have connected, there is no air that is entering. You get it? It must be continuous such that no air enters. For example, you have seen these tubes that they use if they're giving, is it called what? If you are sick and then they put what? They put the medicine in that container. It's called what?
Cannula.
Yeah? Cannula?
They call
Yes,
it
cannula.
That one. They don't put wallagy. So they use that tube that you see. For it, you can use it. And you put one container up and you put another container down. And then afterwards, You put
Teacher, another thing.
you put this tube inside the container that is up, you put it inside the water, and then in the one which is at the bottom, you don't put it in the water. So you try to suck, you first suck out that water, and then the moment you suck out that water will continuously start flowing.
No.
Another question? Do you have any other? So let us draw that diagram there and let us explain what takes place. Do you have any other question?
No.
All right, let us proceed now. Let us draw this diagram. I'm drawing and I hope you are also drawing. My camera is shifting.
Yes, we are drawing.
Okay, good. Who's this one who said the milkshake? You man.
Yeah. Because
We
the
do.
milk, they give them bigger straws when you're taking.
When did you last take it? Maybe when you were
It's so
around.
dumb.
Maybe when
I've
around
taken a month.
Last week.
3 years. Last week.
I've taken a month without taking.
Without taking
He's
this.
so
Why don't you get used to what you can take? Yeah? Like water, those things. Yeah?
No, I'm not
Matunda.
used to water. I'm not used.
And water is light.
Ani
so-
mkomboti.
Minutes.
Didn't you take a mkomboti? Okay. You sleep one day and then you stay there in bed for a full day. You start taking such. Okay, so here we can put also another container here to make it so interesting. Isn't it? You're not caning your sister. Eh?
Yes, teacher.
You're not caning your sister. Eh?
No.
Okay. So you can make it interesting like that. And we have water here and it is coming out. So here it has entered. Where is Amida? Amida, are you there?
Yes.
Okay. I thought you had taken off.
No, I'm there.
Do you also take milkshake? Is it milkshake? What?
Yes.
Usera what? I don't know.
No milkshake.
Teacher, a milkshake, it's like it has ice cream, then down it's milk,
You here.
then the cream out.
For me, I
Yeah.
don't take those things, my friend. They make your body weaker.
Yes.
You
Okay.
only take yogurt.
Hey, you get yogurt and put milk. Okay. I've had. Okay, so this is H. So finished? Have you finished drawing?
No.
So here we can put arrows to show that there is atmospheric what? Pressure. Atmospheric pressure. Okay. You are copying from there, isn't it? So I can change the other way. How does a siphon work? How does a siphon work? How a siphon works? Now, when you come back to school, we shall not repeat these things, okay?
Yes.
If you repeat, then you'll be at a good advantage. So how does a siphon work? So they are saying that pressure at A and D is atmospheric pressure. Therefore, the pressure at E is atmospheric pressure plus pressure due to the column of the water. So pressure at A is the atmospheric pressure, and that atmospheric pressure pushes the water into the what? Into the tube AB. So right, the atmospheric pressure above the liquid pushes it through the tube, AB. Okay, so through that tube AB, that atmospheric pressure will make the water to rise through that tube from A to B. Okay, so what will happen? So they are saying that the column of the water DE, from D to E, the column of the water DE, let me repeat, the pressure at A and D is atmospheric pressure. Therefore, the pressure at E is atmospheric pressure plus pressure due to the column DE. So, okay, hence the water at E can push its way out. Okay, here they do not explain it very well, so we can explain it very well here. So the water between C and D is acted upon by the force of gravity and it falls freely. So we can say the water from point E to D is by gravitation force. There's gravitation force and pressure. It is acted upon by the gravitational force and also the pressure. Remember, pressure in liquids, we said pressure in liquids depends on the force of gravity also. So that pressure that is here in this liquid here, from here up to here, that pressure is due to the force of gravity. So the water from point E, from point C, not E, from point C to E, from point C to E is acted upon by the gravitational force and falls freely into the container at the container below, into the container below. So that continuous flow of the water will make that water to flow from the upper container to the bottom container. So the continuous flow makes the water to flow from the upper container to the bottom one. Now, the reason why this upper container, yes.
First, repeat on that point.
The continuous flow of the water, the continuous flow of the water, the continuous flow of the water. The continuous flow makes the flow. Okay, the continuous flow makes water to flow from the upper container to the bottom one. That continuous flow from point A to point E, that's what we are talking about. So it makes the water to flow from this downer container to the bottom, from the upper container to the bottom container. And then the reason why they put that container upwards there is because they want to increase on this height here. So at this point here, remember that there is a certain pressure, and that pressure depends also on the depth. That's why they are saying that we have H rho G. So there is that G there, which is the gravitation force that causes that pressure also to that causes this weight of the water to fall down freely. Why does it fall down freely? Because there is a force of gravity that is acting on it. And that force of gravity also causes a pressure. So they are saying that also this water which is here is not also acted upon by only gravity, but also with atmospheric pressure, because atmospheric pressure acts in all directions. So atmospheric pressure will act in all directions. So even in this water which is here, it will have atmospheric pressure that is acting on it, and it will make that water to flow downwards into the bottom container. Okay, so there are two things here. The atmospheric pressure makes it to rise, and then what makes this water to fall down? One is the weight of that water or the gravitational force, and then the other one is also due to the atmospheric what? Due to the atmospheric pressure. So members, I think we can end here today. So next time when we meet, I want you to copy these notes, and then when we meet, we shall look at immiscible liquids. Miscible liquids and immiscible liquids. And we shall understand how we can get the densities of different liquids if they are miscible. Miscible, it means that they can be mixed. If they are immiscible, it means that they cannot be mixed together. For example, paraffin and water cannot mix each other. So why don't you have a great day today? And we meet next week.
As you wish.
All right. Bye-bye. Neha, Soya, bye-bye. Lynette.